So this is a full stack development with Java and NoSQL. This is mostly about Java and Couchbase because I work at Couchbase. My name is Laurent Doguin. I'm a French developer advocate for Couchbase based in Paris. What else can I tell you about me? Not much. You can follow me on Twitter. You can send me an email. Usually I answer to people. So if you have any question about Couchbase, please do send me a question, an email, whatever. And we're going to start by talking about Couchbase and how it fits very well into the modern way of developing application in the full stack development. First thing, what is Couchbase? Mostly 5 things. We could add more of those, but if you want to summarize everything, it is a key value store that has a managed cache, and if the value is a JSON document, then become a document database because you can query all those values based on the value part, not the key part anymore. And we also have an embedded database that runs in-app on mobile or natively on Java, so it works on Raspberry Pi. It's very, very lightweight, and iOS and every cool new runtime that syncs automatically to Couchbase server through the piece on the far right called the sync gateway, which is this thing. We could add more objective. It's a masterless distributed database. It's also, since, well, in 2 weeks, will be a full-text database. Full-text is still in developer preview, but you can actually do you'll be able to build full-text index in Couchbase. And it's great. It's a sponsored talk. So where is NoSQL a good fit? There's two ways of seeing this, the good fit and the bad fit. Couchbase, not necessarily NoSQL, but at least Couchbase, everything's in memory. Everything is nicely distributed. If it's in memory, when you want the data, you don't have to read on disk. If you don't have to read on disk, then it's really fast. Then it's pretty good for low latency application. Just a quick example, Criteo in French is retargeting advertisements. They just published a blog today about the architecture. They use Kafka to send lots of data to a really big, massive Hadoop cluster. I think it's one of the biggest in Europe. And once they've computed everything, they store this into Couchbase so that when you actually load the page, they can very quickly get the information out of Couchbase to make sure they display an ad that you will maybe, probably, at least they hope so, click on it so that they can make money out of it. So low latency is critical. Basically, NoSQL came up during the beginning of the cloud era, so think 2006, 7, 8, in those years. Which is pretty much when Amazon as well did the AWS services. And everything came up pretty much at the same time for one very good reason, is that we had more and more people connected to the internet, we had more and more users, we had more throughput was needed because they want to read or sometimes they want to write lots of data. So you need a distributed database, which is why NoSQL is a good fit, because most of the NoSQL store, it's not only because it's unstructured, it's mostly because it can be distributed and sustain a very high write or read load. Another good thing, if you need to have big clusters, maybe sometimes it's just at one particular moment. Let's take a TV show, and maybe the people that watch the TV show can vote on something, and usually they do that during the TV shows, which is basically maybe on Tuesday between 9 and 10, which is the moment where you need a very big cluster because everybody's going to write and vote at the same time. But then it would be really expensive to keep that very, very big cluster for forever. You only need it on a Tuesday, right? So the good thing is, most of NoSQL store gives you this elasticity, which is I can grow up my cluster really fast, sustain that peak, that load, and then grew small again to, have more money and stop spending it. And it's not only about money, it's also a lot about energy. If we can be as carbon friendly as possible, also is good. So it's a great fit for that. It's a great fit for caching use case. That's the predominantly direct document access. What that means is you're showing a page. Traditionally, you would do a query to a SQL database, lots of tables, some joins, get a result set, map the result set to an object, and then send those objects to your app and then map it maybe into JSON showing the page, which is kind of slow and long. And what you would do, what would be better, is just give me an object that has everything I need for my current page, which is what you can do easily with NoSQL store, with key value store in particular. Where it is not good at, I don't like the term legacy business app. Business app probably is fine. We don't have full asset support because we're distributed. So the transaction part, if you were to support transaction, that would be very slow because then you would have to block the whole cluster during the transaction. So several machines. Actually, it runs on commodity hardware. You can have any kind of hardware, decent cloud hardware you want. Depending on the use case you have. So Criteo, they have 256 gig of RAM on each of the machine. They have a huge cluster. And we have another customer that have 2 terabytes of RAM on each machine. So, it depends what you want to do. But yeah, we support everything. But the best idea to remember on that is that we scale out, not up. I mean, you can scale up, but SQL database can only scale up. They cannot scale out. Unless you do sharding manually, unless you do a master-slave architecture, unless you put the effort into it. But traditionally, in the SQL database, they can scale in every way pretty easily. Develop with agility. Basically, we use JSON. It's an unstructured format. It's extremely flexible. It's fast because everybody pretty much develop in JSON right now. Is there any of you using XML still? Yeah? XML for sending data from the database to your application. XML with configuration, it's fine. It's legacy. It works. I prefer YAML, but I used to use an object database called BerkeleyDB. It was an XML database, and it was a long time ago. And I was actually getting the XML and then mapping into my web page, which is an absolute nightmare. And now everybody does JSON, and from the show hand, I could see you're in the same position. Most of the people use JSON. JSON is key value, so if you store JSON, you want to be able to query that JSON, which is what Couchbase offers, and I will send you more details about it later on. We have a language called Nickel. It's basically SQL for JSON, which was part of my previous talk today, and what it is really just SQL. So we have a JDBC driver that allows you to integrate to all the current SQL ecosystem, which is pretty cool. We also have Hadoop or Spark connectors, and we also run on mobile, which is pretty much everything the modern developer needs to do. And he also needs to, from an operative perspective, do some other stuff. That was the more of a feature perspective. Now, from an operative perspective, if you run ops, you need to have that elastic scalability. You need to be fast, because basically, if you load a page, if you're like me, and if it doesn't load in the next 2 seconds, then you will probably just forget about it and do something else. If it's extremely important, you will wait, but you get the idea. If you're faster, then it's always better. And obviously, you want your service to be always on. Like if you're an online store, you're not closing at night. It's just 7 days a week, 24 hours a day. So how do you do upgrade? How do you do maintenance? How do you do all these kind of things? What Couchbase allows you to do, rolling upgrade and stay online forever, supposedly. A lot of our customers use us because of that, because we can actually be up and sustain those 5/9 that they want to, which is, it means you can be off 4 hours a year, maybe a little more, but so it's kind of a challenge. Another thing we're really good at is multi-data center deployment, which is the traditional use case is geographical replication. You have a data center in Europe, you're in the US, there is one latency that you cannot move, that's the size of the optic fiber between the US and your data center in Europe. There is no way you can be faster than the latency. So to cope with that problem, what you can do is install another cluster in the US and then have active-active replication between the two clusters, which is also why most of our customers use us. And of course, because you want ops, you want simple and powerful administration. Everything is REST-based. We have a web UI that's basically an Angular application wrapped on top of that REST API, and command line tools that are also wrapped around that REST API, which makes it really easy to integrate with Docker Compose or Mesos or all these cool new orchestrating toys that are really good. And this is something that's fairly new in the NoSQL world. but is expected from all the SQL people, and it's security. There's different levels to that. Mostly SQL has been, people that use SQL, they are expecting to have the same thing, right? It's a database, I should have the same level of security. Well, the thing is, you have table, you have columns, you have users. We mostly have one KV store, so it doesn't really apply. We store objects. We don't know the schema, so you can't say, I'm going to grant write on this particular field in JSON. That doesn't make any sense. So we have read and write on a bucket. We have a lot of audit functionality on the administration side of things. But what you have to keep in mind is that traditionally on SQL, the application security was actually sometimes in the SQL database. It's not something you can do anymore with NoSQL. Application security, application layer. The security you have on your database is operative security, which means making sure that everything is encrypted with SSL when you do active replication between data center or inside the data center, making sure that your call from the client to the database is also encrypted, all these things. It's DevOps Java conference, but if you do other stuff than Java, we support lots of languages, C, Java, Go, Node.js, PHP, Ruby, Python. There's more that are more community-oriented, so if you write Perl, there's actually an SDK for Perl and Erlang as well. We support most of the traditional framework associated to those languages. We have very, very strong integration with the Spring ecosystem. We have a new version of Spring Data Couchbase that got out 2-3 weeks ago, fully integrated with Spring Boot and the auto-configure stuff. We really like Spring. Spring 5 is going to be all about Reactor, which is the reactive way of doing web application. And our Java SDK is actually based on RxJava internally, which makes it a very good fit for Spring 5 and Reactor. Lots of other different platform or framework. We certify that Couchbase is going to run on this platform, on Docker, on Red Hat, on SUSE, on Ubuntu, whatever, and on all those cloud providers as well. So Docker, Giant is pretty cool. It's Solaris people. Who here remembers of Solaris or knows Solaris? Some of you. Solaris was an Oracle operating system, and they had this thing called Zone, which is pretty much a container, but they didn't have the Docker run command or the Docker file, so basically no one knew what it was. And now since Docker is out, they did something called the Linux Zone, which is basically running Docker container on Solaris, and it's a great operating system, and that's how Giant propose you to host your Docker containers, and they're a Couchbase partner. In the big data side of things, there is the native connectors and there is the non-native connectors. Native connectors, Hadoop, Spark, essentially. And then you have all the JDBC compliant tool that we can integrate with because Couchbase actually have a JDBC driver, which is really nice. We have a plugin for Elasticsearch. I think half of our customers have this, at least, maybe more than half. Elastic is great. We do have full text coming up in the next version, but our goal is not to be as good as Elastic. I mean, it is, but that's not the point. If you like Elastic and you want to use Elastic, please do. We can do 80% maybe of what Elastic does. So, if you don't need to deploy it, it's always better. It's always simpler in terms of operation. So that's why we are integrating full text search as well in Couchbase. Quick word about the architecture of Couchbase. You see a cluster of Couchbase server nodes, and you see a couple of services running around. Data, query, and index services are the one you will use the most as a developer. The data service is basically where you write stuff. The query service is how you query stuff, and the index service. You see what I mean? We have a caching layer. Everything you do in Couchbase starts in the cache, which means starts in RAM. So when you write or read something, it is in RAM. When you do key value get or when you scan an index, they're all in RAM, which makes it fast and great for low latency application. Then the storage layer, which is pretty much the data layer, and the cluster manager. Couchbase is masterless. There is no master. There is no controller node. There is no slave node. There is no master node. It's just one kind of node. Every node can be a manager. Every node can ping each other to make sure that everyone is still here, that you don't need to do failover and all these things. So it's very simple to scale because it's just one node after the other. Now, from an administration perspective, if you run ops, you're always happy to know that we have a web UI, which you see here. I will show you a demo later on of the app, of the web UI, sorry, which is, as I said, wrapped on top of REST API. So, any questions so far? No. Couchbase is a key value store. It becomes a document database once you store JSON documents as a value, because that's when you can do query. So, talk a bit about JSON first, compared to traditional table and columns. Usually when you want to represent a real object in SQL, you have several tables, several columns. You do join across them, you get a result set. You take that result set, you map it to a business object, and then you can actually use it, and maybe you will actually map that business object to a JSON object and then send it to your AngularJS front. Which it's fine, it works, but it's a lot of work compared to just storing a JSON document, doing a key value get directly from the JavaScript app, and you know, you're good to go. So that's what's nice about JSON, is that everybody uses it now, and it sort of have an inferred schema inside the JSON document. When they say that NoSQL is schemaless, it's not completely true. There is a schema, it's just that inside each JSON document could be a different schema. You don't have to think about all the tables and columns and types before. Just as you write JSON documents, inside the JSON documents, you have fields, they have a name, they have a type. You can have complex type, like object and arrays, which in SQL would probably translate to having maybe a join to another table to represent lists, stuff like this. So it's really much more natural in the way developers develop these days. There is 3 ways to query or to get data out of Couchbase. 4 if you use the full text search, but it's coming in 2 weeks in Couchbase 4.5. The first one is key value. Again, the value could be anything, could be a cellular Java session. We have a lot of people that use Couchbase just for a caching session store or user session store. When you log in the Apple Store, basically your session is stored in Couchbase, which is nice. Like on pretty much more than 1 billion sessions, so gives you a good idea of how Couchbase can scale. Key value, it's what Redis used to do, now they do more and more stuff. It's what React does, it's Memcache. Couchbase comes from 2 products. 5 years ago it was Memcache, the distributed version of Memcache called Membase, and CouchDB. And Memcache was a very popular key value store for more than 15 years, and still is. And Couchbase is a drop-in replacement for Memcache. So key value is great. It's not because you can do SQL queries on JSON document that you need to forget about key value. Key value will always be faster because you don't have to scan any index. You have a key, get the object in RAM, below the millisecond. It's really, really fast. Then we have the views. The views is similar to a materialized view in SQL. Could be seen as a static queries because you have to think about the query and create the index before running the query. In SQL, you have just a primary index and you run any query you want instead of querying. With the views, materialized view, you first create an index. In Couchbase, it's using a MapReduce function. Every JSON document you write goes into the map function. The map function allows you to add an entry or more to an index, and then the reduce function gives you one object based on that index. So you can do some very lightweight analytics and interesting things like this, importing dashboard. You probably want to use something like Spark for more complicated stuff, but it's doable. And views also supports a multidimensional query, which is really nice because a 2D query is a geospatial query. And you can actually add more dimensions. So you could do a query that says, give me all the documents that are in that box, in that space, that are coffee shops, that are not Starbucks, that open at 10 and that close before 8. So that's I don't know, maybe 6-dimension query. It's something you can build easily using the view system. But you need to think about the index and create the index first and then do the query. And the third one, which is a really cool new one that got out a year ago, is querying using Nickel. It's an SQL language, which you can see in the first example, select stuff from, where, like, etc. Just basic SQL with more stuff because you're not dealing with simple data structure like table and columns, you're dealing with JSON document, which means there could be an array, there could be an object, it could be an object with some arrays, there could be an array of objects. I mean, yeah. So we have all the keywords and functionality in NoSQL to query all those complex structure. We are also the only data store that supports joins out of the box. You cannot do join with Cassandra, you cannot do join with Mongo, you can with Couchbase. Unless you use Spark with Cassandra or dupe and drill with Mongo or whatever, which makes Couchbase unique in that sense. And we have an NDBC and JDBC driver. So our SDK, to interface, as I told you, it's based on RxJava. Maybe you don't want to wrap your hand around reactive programming yet when you start with Couchbase. Maybe you just want to do classic synchronous blocking programming, which is fine. You still get all the benefits in terms of speed of reactive, because under the hood it's all built on RxJava. So it's an event-based system, a bit like Node.js or Vertex or Netty, because that's what it's based on. Compatible with various Java frameworks, yes, obviously. It's just basically it's a big fat jar. We bundle every dependency so that you don't have any dependency issue. If you already use another version of Java, it's fine. Everything is bundled nicely in the SDK, and Netty as well. So it's pretty easy to use. Very well integrated with Spring. I did a lot of stuff with Ratpack previously. That's the example I will show you in a minute. Basic API. How do you get a connection to a Couchbase cluster? There's a factory, Couchbase cluster.create. Give it one IP. You probably want to give more than one IP. In the real world, usually you have a cluster of several machines. If one machine goes down, and that was the IP that I just gave, then I don't have any connection to the cluster anymore. So you just give 3 or 4 seeds. And what it does when doing the creating the connection to the cluster is asking one of those nodes, can you send me back the cluster map? The cluster map is the topology of the cluster. It sends you all the addresses of all the nodes that are part of the cluster, as well as all the buckets. A bucket is like a schema in SQL, is where you store your key value pairs, and it tells you this part of the bucket is on this machine, this part of the bucket is on this machine, etc., etc. So the SDK, the client, always knows where are the different parts of bucket. A bucket is split into several parts because we do automatic sharding. When you write a key value pair, we take the key, we hash the key, it gives us an internal ID. This internal ID that starts from 0 and ends with Z goes to virtual partition number 1. And because I have the cluster map, I know that this virtual partition is on this machine, so it's extremely fast. When you do key value get or set, we have the key, we know exactly which machine to ask for the document or where to write the document, and it's in RAM, so it is below the millisecond in terms of latency. So creating a connection, getting the cluster map, I have the cluster map. Now I will open a connection to a bucket, which is where you store documents or key value pairs. A bucket has a name and can be protected by a password. And now how do you write something? Most of the objects in Couchbase SDK, and Java SDK at least, follow the same principle. If you need a new instance, then there's a static method to create or to create it from something else. So here I create a JSON object. I put a field called name, John, and then from the JSON object, I create a JSON document. And a JSON document, it's an object, the value part, and an ID. I talked about key value, so ID, key, is pretty much the same thing. You create an instance of JSON documents, and then you call the insert method and insert the documents inside the bucket. That's pretty much what you can do. And once you've stored many documents, you want to query them. So I have a function that takes a bucket as parameters, and I'm running a very stupid simple query, select star from the name of my bucket, which is give me all the documents in my bucket, which you should probably not do in real life, but that's a very simple example to understand. I'm building an equal query using the simple factory method, which basically take a string, give me a query, run that query. Did it succeed? Yes. Wonderful. No. Exception. If it succeeded, get all the rows, create a list, and return all the rows. That's the synchronous blocking way of doing things. And because we use RxJava, there is another way, and I will show that to you in a minute. This is a more complex query to show you that you can do any traditional SQL keywords. You can use union, you can use a subquery, you can see there's a subselect in that query. You could do join, anything really. We support parameter as well, which is the third line from the bottom, which is, this is a JSON array. You can also give a JSON object. If you give a JSON array, the parameters would be $1, $2. If you give a JSON object, then this name field, so it will be $name of the field. It's pretty basic stuff. Demo time, yeah. Hopefully I'm in mirror mode. Yes, good. I don't know if I've run that application yet. Let's see. It's a very basic app that allows you to store a user in Couchbase using Ratpack, because Ratpack is really cool and because I love Ratpack. Gotta delete those. This is an AngularJS front, very basic. I'll show you the code next. Just creating a user, blah blah blah, blah blah blah. Save. I have a list of users. I can create another user. Another user. You can edit everything. Well, basic application. Wow. The interesting part, of course, is the code. I will show you the whole application code because it's really, really small. Doesn't do much, as I said. I'm going to go very quick on the Angular one because it's JavaScript and it's a Java conference, so who cares? I'm sorry if you came to see some JavaScript. It's an Angular application. There are basically three functions. Save a user, delete a user, edit a user, which is go on the template and save a user, so it's still the same function, and list the whole user. And what it does for the list is so that's the routing part. This is where you define all your templates. And the interesting part is the controller part, which is where you define the call to the backend, which is the Java app I'm going to show you in a minute. Basically, get all the documents just to get a call to. Also, if there is any RESTful, very opinionated people, this is probably one of the worst REST API, so I apologize for that, but that's just for an example. So if there's a REST Nazi here, I'm sorry. Just do a get. It returns to me an array of JSON objects, which is something very easy to manipulate in JavaScript, so it's really, really natural. I don't have to do any kind of mapping. I just ask Couchbase to give me a result of all the things I need, and that's basically what happens here. I have a JSON object array. I put all the array into the items scope because it's double binding, so if it's in the scope here, then it's what's going to happen in the template. Pretty much the same thing for the get, and for the delete is just a post based on the document ID, and for the save it's not just the document ID, I'm posting a complete JSON object, which again is something very natural when you do Couchbase and JavaScript. So, is any of you familiar with Ratpack? Cool. In the previous example, the previous people that did this presentation, it was actually a Spring Boot application. And I like Spring Boot, and I like the way you can do dependency injection with Spring Boot, and I like the way Spring Boot auto-configures everything for you. So it's still a Spring Boot application, but the whole Spring MVC part has been replaced by what you see here, which is a Ratpack handler. So two annotation, Spring Boot app, it is a Spring Boot app. Enable Ratpack, which means all the routing, all the web writing will go through this action chain, which is the Ratpack way of defining URL handlers. And all you have to do is basically run the application as you would. And because I'm using RxJava, I need to initialize the RxJava post thread and everything in my Spring application. So I have two examples. I will show you the synchronous code first, and then the traditional Spring Boot code, and then I will show you how I changed it to work with Ratpack and RxJava. So I talked about that. You could do data rendering directly in the templates. It works. It's been done for years. Now the trend is more about separating front and backend. So usually you create your front application in Angular. It calls a bunch of services on the backend, and when you decouple that, it makes it much more easier to maintain, to update, to upgrade, etc., etc. So that's what the example we did here. And the idea is, you can have multiple front end and just one backend. Could be mobile, could be web, could be your PlayStation 4, maybe whatever you want. So Java backend. This is what you would have to do to configure your access to Couchbase without the auto magical configuration provided by Spring Boot, which is defining a properties file, giving the host name of your Couchbase cluster. Could be one IP, could be several IP, giving the name of a bucket you want to connect to and a password. How would it look like if you save a document? This is Spring MVC. As a request body, you get the JSON document that I showed you just before. Map that JSON object, map that JSON document to a JSON object. It's all using Jackson behind that. Make sure that the document is valid. If it's not, send a bad, angry response. And if it's valid, then call the database service and then save the document. Pretty much the same thing for get. We don't have to go into details on this. It's not in the right order. I will show you that first and then come back to that slide. The save method of the service, from a synchronous perspective, here's what it does. It gets the JSON object. It extracts the ID, if there is one. If there is none, then it generates a new ID, which is basically the difference between creating a document and editing an existing document. And here, what we do, it's interesting because you are actually just changing one document. So you could do a key value get, you could do bucket.insert and, or upsert because it's a mix of update and insert. Then here I'm showing you an actual NoSQL query because NoSQL is not read-only, it supports insert, update, delete. So what you see is actually a NoSQL query running. You can see I have 1, 2, 3, 4 parameters, $1, $2, $4, which means that when I will create my query, I will use an array as parameters, which is the next line you see here. Run the query, and the query will return to you a NoSQL query results, which is what I just showed you before. Did the query succeed? No. Throw an error. Did the query succeed? Yes. Wrap everything into a list of map and sending back to the client. And this is just an example of the Couchbase UI. I will show you that in detail later on. We don't have to go through all this function. We probably don't have to go through all the AngularJS front-end again because we just did it. There you go. And talk a little bit about RxJava and the asynchronous way of doing things. All the methods you saw were using bucket.query, bucket.update, bucket.insert, and this is the blocking synchronous way of doing things. If you want to do it the synchronous way, which is not the default way because we understand that it's a new thing and that it shouldn't be a default, then you just call bucket.async and it gives you the complete asynchronous API that exposes observable. And observable in the RxJava world is like a stream of objects. An observable is like, so you have your iterable. When you have an iterable, it's just, I send you a big byte array, I don't wait for anything, and it's just, here's your big list, and deal with it. With a stream of data, data comes in as it arrives, so you can actually be, it's like event-based, so it's asynchronous in that sense, and it's non-blocking, the fact that we don't wait for all the string to come in to pass to the second method. You're describing a stream and some operation that you will do on the stream, and then you can move on. which is what you can see here. I use the get method. I just want the document called key1, and then it returns eventually that document. Once it returns that document, it will go through a map function, and that function takes the document, the content of the document, which is a JSON object, and then the string called name, and then subscribe, which is display the name. Which is exactly what I just said. That's nice, but that's a very simple example. So I'll go back to my code, my Ratpack code, and we'll show you, oops, not my emails, but my code. So all of my query, I want to set up cross-origin headers. So what Ratpack allows me to do in my chain of handler is to define an handler for all the queries. And for all the queries, I will get the response headers, and I will add all my cross-origin headers. That's how you would do it. Just make sure that every query will have those headers. Then I can start chaining all the REST API URL that I want to define, which is all the MVC method that I showed you before. So when someone hits happy/get_all, which is what you see here, it's a get as the HTTP verb get, because you can see there's a post here, and obviously there's all the other HTTP verbs supported. When they do a get on happy/get_all, I have a context object that will allow me to get the request, the response, to render some stuff inside this, to render some files. And get all is supposed to give me the whole list of all the documents. By default, Ratpack uses promises. I use RxJava. Promises is another way to do asynchronous non-blocking code. So they did a small wrapper, which is what I'm doing here. I'm converting dataService.getAll, which is my Java method that returns me an observable, as a promise. And once I have my promise, I can start doing some stuff. So let's see what getAll does. It's a simple query. Really select all the fields I need from the bucket. Run the query, and instead of using bucket.query, I use bucket.async.query. I use the flat map operators to get the rows, and for each rows that are coming up, I will simply return a value, which is a JSON object in the Jackson library, no Jackson sense. So once you write that, dataService.getAll, you have an observable. It's wrapped on a promise, which means that when the observable, you get all the documents mapped to a JSON object, then you can actually pass on to the resulting part, and all I want to do is render my JSON object in the context as a string, because, again, Nickel returns to me a JSON object already. I don't have anything else to do to that object. I can just do, this is the object, send in the JSON back to the Angular app, and then, it's all good. You have all your JSON document, and it's fine. It works. This is just for one document. It's pretty much the same thing. Let's go to one more, maybe more interesting one, the save. Because the save takes JSON body in the request. In the request, traditionally you have the headers. This one, because I'm doing a post of an actual JSON object, you need to parse the JSON body. So in the context, there's a method called parse. There's a static method called parseJSON_node, which is what it's doing here. And what it's basically going to do is return to you a JSON node directly. So it's also fully asynchronous. Once everything is parsed, when all the requests is arrived to the server, everything's parsed, you have the JSON node, you can start doing some verification, like maybe rendering an error if you want to, if there's no first name or last name or email, and then do the traditional thing, which is wrap my observable in a promise, wait until the operation is done, and once it's done, render the results. The save method is, that's the example I just showed you before, but the asynchronous one. And there's nothing that changed really except from that part. The query is the same. But the way you get the data out, instead of waiting to have everything, looping on that big fat byte array that you've waited for from the server to your client, it just makes sure that everything as it goes is mapped to a JSON object, and then once it has everything, go into the promised result, and then you can do whatever you want, which is most of the time rendering the response. So that's how you would write a quick full-stack app with a Java backend and an Angular JS front-end with Couchbase. I have 10 minutes to tell you the other part of the full stack stack with Couchbase, which is Couchbase Mobile. Any question first on the Java stuff or the Angular stuff, and I will try to do 5 minutes on mobile, which is very short, and then take more question. No question. Couchbase Mobile is three things, really. It's Couchbase Server, the database I showed you before, something called the Sync Gateway, and something called Couchbase Lite. The Sync Gateway, it's an application server that we've written in Go, because we like Go. It's probably the only reason why. And it's a Couchbase application that exposes a REST API that allow you to do synchronization. Couchbase Lite, it's a JSON database that runs in your app, in Android, iOS, or in Java, or Xamarin if you do Windows Phone, or PouchDB, which is a JavaScript version that runs in your browser and that uses the local storage of your browser. And those databases can synchronize to Couchbase Server through the REST API of the Sync Gateway. So that's how it works. Couchbase Lite, lightweight database, it is pure JSON, it is independent. If you do mobile development and you don't need a server part, but you do need a local database, you could use SQLite, or you could use Couchbase Lite because maybe you are more familiar with storing JSON than doing tables and column again on mobile. And if you did once a schema migration on server, where you control everything, it's just one server, then I will let you imagine how you migrate SQL schema on other people's phone where you don't know what happened and you don't have any control on that. So it's probably more natural to do JSON on mobile. Yeah, just a couple of words. I said iOS, Android. The native Java version runs anywhere you can run a JVM. We also have a Unity, PhoneGap, and Xamarin version as well. And PouchDB, that's the JavaScript version that runs on anything. So the Sync Gateway, this REST API that sits in the middle of Couchbase Server and all these clients, brings you several features. You can really see the Sync Gateway as an application written for Couchbase. It gives you synchronization, encrypted synchronization with SSL, or basic authentication. We also support OAuth and OpenID. You can add your own providers, you can add your own way of authenticating user, your own session store, all these things. And basically allow you from the client or with the REST API to do read and write and to synchronize to the Couchbase server that I already talked about, and I'm not going to say much more about it. Basically, 4 features of Couchbase Lite are represented here. It is a document database. Because it's a document database and NoSQL is not available on mobile because it's too much CPU consumption, you can create indexes with the MapReduce function, just like you would do traditionally with materialized views. And once you have those indexes, you can run your query on your local JSON documents. It is event-based, which is to say when you have a replication coming in, as a developer, you can subscribe to changes, you can add listener and maybe listen to conflicts, because if you go offline or online again, maybe you'll see conflict. And it syncs to the Sync Gateway. This is the Android example. How do you set up a local database? You create a context. The context is basically, this is where I'm going to write the file of my JSON database. Then you create a map of string and object, because a JSON document is nothing but a map of string and objects. With the database, you can convert that, you can create new documents and then put that map as value of the document. So it's that key value thing again. This JSON database is just a key value store that runs in mobile and to which you can add any JSON document. This is the MapReduce index. It's written in Java for Android. It's written in Objective-C or Swift if you do iOS, native language. It's really easy to debug, and it's persisted. So this is an example. This is a map function that allows you to create an index, assuming that every document have a field called created at. So it's going to give you an index of all the documents sorted by creation date. And because you can listen to notification, one of the cool things about this, you can do one listener on one document, but one of the great things is you can actually update the index real time based on the replication that comes up from the server, because it's event-based. So there's actually a thread on the background that waits for all these notifications to happen, take the new modification, updates the index, and if your user is actually watching a page with that index, then it can be updated in real time based on the fact that it's event-based, which is really nice. This is just a listener example. You take a document, add a change listener, define a listener, and decide what you want to do with that listener. Like conflicts. And then there's the sync function. This is how you connect your local database to Couchbase server. And it's really, really simple. You create what we call a replication link. There's two kinds of replication link, push and pull. Pull, I get the data out of the server to my machine. Push, I push my data to the server. There's an option called set continuous. What it does is basically open a WebSocket, which is great for demos and horrible for your phone battery, but allow you to do real time, which is always nice. You can eventually, maybe if you want to add an authenticator to make sure that you are connected to the sync gateway, your sync gateway is not open to the whole world. So you have security, you can add changes to a replication, and then all you have to do is start the replication. If it's real time, it will keep on replicating. Everything is available on the traditional repository, so JCenter, Maven Central for Java. There's NuGet for the Xamarin stuff. Sources are on GitHub. It is fully open source. I haven't said that. Sorry, Couchbase is Apache too. Everything's open source. If you want, we have stickers. All of the stickers at the booth. We also have cupcakes at the booth. Cupcakes are nice. You should join. This is a summary, but mostly for reference. If you want to look at those slides later, if you want to start playing with Couchbase and Java, here's a bunch of sample we have. Here's how you can contact us. And now we have 2 minutes for question, which was really fast, and I apologize for that.
Why do you write so many one-liners? I mean, in Java code, it's not possible to read that code.
It's the easiest way to decouple stuff, to show them, really. That's why it is. Yeah, I know. I should write a Perl example on one line. The whole thing. I haven't talked much about Couchbase Mobile from a business perspective. What we aim to fix, the problem we want to fix with Couchbase Mobile is offline synchronization. I just talked about the architecture, but actually the goal of having a local database that can sync to a remote database is that you don't always have network. Most of the time, if you have a crappy network, then you have a crappy app because it's slow to give you the data. If you don't have any network, you don't have any data, so you probably want a local database. But then if you have only a local database, then you cannot update anything unless you update the whole application through the store. So that's why it makes sense to have a local database that can sync automatically to the server part. And there's a lot of logic to put on the server part, because when you go offline and online again, especially if you create content or edit content, then you will have conflict. If you have conflict, basically you need user, security, permission, and revisions to be able to handle this conflict. And that's the good thing about the event-based side of things, that when you have a conflict, which is something very business, it's a business problem. How do you resolve a conflict? It's pretty easy. You could choose the biggest branch, but it doesn't really make sense from a business perspective. So because it's event-based, you have the two revision, the new one, the two conflicting revision, and then you can decide what to do with them. Maybe there's a field called last update, and that's the one you're going to choose. Or maybe you're going to actually show a screen to the user so that he can actually manually handle the conflict, because it makes sense from a business perspective. And all of these things that are really, really painful to implement manually yourself are handled by Couchbase Mobile, which is why Couchbase Mobile is so cool, and which is why Couchbase generally allows you to address a lot of different use cases. It's probably one of the most versatile databases out there. Time's up. Thank you.